In this series that I introduced today, we shall be dealing with different kinds of polynomials with different forms. Let me give you a few examples of polynomials. For example, x cubed to minus 5x plus 6, that is a polynomial to the degree 3. We consider the highest degree and we call it a polynomial with the highest degree, which is degree 3. Ax squared plus bx plus c is a polynomial of degree 2. And polynomials of degree 2 are what we actually call quadratic equations. Then a linear function is a polynomial to degree 1. Now when we say degree 1, degree 2, degree 3, we are actually talking about the highest power in that equation. Because here, if you look at this one, for example, this x has got to the power 1, but we will only look at the highest power, and that is how the name is baptized. So in our subsequent videos, we shall be exploring polynomials in terms of the remainder theorem, the factor theorem. We'll look at synthetic divisions, we'll look at solutions of equations that are simultaneous, equations that are non-simultaneous, and so on and so on. The remainder theorem. If the remainder is required when a polynomial is divided by a linear function, it can be obtained by long division. Let's look at this example. Find the remainder when this polynomial is divided by this linear function. So we're going to use long division to sort that. It is divided by that, so it is going to be x plus 3, and this is it, the x cubed plus 3x squared minus 4x plus 1. So we start our long division. So we begin. It's going to be x cubed divided by x will give us x squared. So x squared times this whole thing. X squared times x is going to be x cubed. X squared plus 3x is going to give us plus 3x squared. When we subtract these two, this minus that will give us that, this minus that will give us 0. So we pull down this remaining, it's negative 4x, so we bring down negative 4x. We start the process again. Negative 4x, divide that by x, you'll get negative 4. Negative 4 times x is going to give us negative 4x. The negative 4x times 3 is going to give us negative 12. When we subtract those two, negative 4x minus negative 4 will give us 0. This will be nothing. 1 minus negative 12 is going to give us a positive 13. And so that becomes our remainder. So we have divided, the remainder is 13. We have divided this polynomial by that. So this becomes our divisor. Another example. Find the remainder when x cubed minus 2x squared plus 5x plus 8 is divided by x minus 2. We'll do long division, so it is x minus 2 there, and then we have this x cubed minus 2x squared plus 5x plus 8. So we begin. X cubed divided by x, you remain with x squared. X squared times x is going to become x cubed. Then x squared times minus 2 will give us minus 2x squared. When we subtract that from that, x cubed minus x cubed gives us nothing. Minus 2x squared minus negative 2x squared will give us nothing. So we bring down these two down. So what we are remaining with here is plus 5x plus 8. We continue. 5x divided by x will give us positive 5. So it's positive 5. Positive 5 times x will give us positive 5x. And also this 5 times this negative 2 will give us minus 10, because it's positive 5 times negative 2, so it gives us negative 10. We subtract these two. 5x minus 5x gives us nothing. 8 minus negative 10 gives us, this is going to become a positive, so it becomes 18. So it means that our remainder will be 18. Our divisor is x minus 2, and our quotient is x squared plus 5, and this is going to be our polynomial. So now take note that the division will end when the remainder has a degree that is less than the divisor. That is when it will end. So therefore, when x cubed is divided by x minus 2, it means that we are going to get our answer as x squared plus 5, and our remainder will always be 18. When this polynomial is divided by x plus 3, which is the divisor, we shall get our answer, which we should call the quotient, as x squared minus 4, and our remainder will be 13. So we can express this in a different way. When we got this x cubed minus 2x minus 2x squared plus 5x plus 8, when we divided that by x minus 2, that gave us x squared plus 5 as our answer, plus the remainder, which is 18. So it means that if we made this a flat equation, we multiply x minus 2 on both sides, this remains this way, so it becomes x cubed minus 2x squared plus 5x plus 8 is going to be equal to x minus 2. We have multiplied x minus 2 on both sides, so it's x minus 2. Multiply that by the quotient, which is x squared plus 5 plus the remainder. That's going to be plus 18, which is the remainder. So it means, in general terms, we can call this polynomial p of x. So it means, in general terms, p of x x minus a here is going to be our divisor. So it's going to be, the polynomial is going to be equal to the quotient, which is still a function, times x minus a, which is the divisor, plus the remainder. And this general term is what we are calling the remainder theorem. Let's do an example to this effect. If you look at this question, they're asking us to find the remainder when this polynomial is divided by this divisor. So for us to be able to divide this divisor by this polynomial so that we're able to get a remainder, this should be equal to 0. So meaning that for us to continue x, solving this number, we're not going to use long division. We are trying to use this expression that we have gotten, that p of x is going to be equal to the quotient of x, multiply that by the divisor, which is x minus a, plus the remainder. Let's call the remainder r. So it means that for us to get this remainder, it means that this whole this should be equal to 0 for us to get that value of r. So it means, for us to get the remainder, it means that the value of x should be, this x whole expression should be equal to 0, and it means that this, multiply that by that. For this to be 0, either this must be 0 or the quotient must be 0. We do not have the quotient, but we have the divisor, which is x minus 2. So if x minus 2 is equal to 0, what is the value of x? So we get the value of x that is going to enable this expression to be 0, so that we are able to find the remainder. So this is going to be, for this to be equal to 0, it means that x minus 2 should be equal to 0. So if x minus 2 is equal to 0, it means that the value of x here should be 2. So it means we come and substitute it in this equation. So it means that the polynomial px, which is equal to q into x minus a plus r, the polynomial is going to be equal to the quotient. It's a product of the quotient. You get the quotient, multiply that by the divisor, and you add the remainder. Now, if this value of x is equal to a. So we can have x minus 2, x minus 1, x minus 3. Now if the value of x is the same as a, then it means that this whole term is going to be equal to 0. If this whole term is going to be equal to 0, it means that the polynomial which is p of x is going to be equal to r. Now this is what we are calling the remainder theorem. And if we want to find the remainder after getting a polynomial and dividing it by a certain divisor, then it means that our value of x should minus a, this term, the divisor should be equal to 0. So let's do an example to this effect. According to the remainder theorem, the value of x minus 2 is equal to 0, so x is 2. So that was our value of s, so x is 2. So it means that this whole terminology is going to die, and according to the remainder theorem, our polynomial p of x will be equal to r. Now our polynomial here in our question is x cubed plus minus that plus that and that. So it's going to become x cubed minus 2x squared plus 5x plus 8 is going to give us our remainder. Now our value of x is 2. So it means it's going to be 2 cubed minus 2 times 2 squared plus 5 times 2 plus 8 is giving us our remainder. Today we get to look at the factor theorem. In our previous video we said that when you get a polynomial and you multiply the quotient by the divisor and you add the remainder, then you get the polynomial. This was derived in our previous video. We arrived at this in our previous video when we were looking at the remainder theorem, and we said that for us to get the value of r, then x minus a should be equal to 0. It means that this whole term will have to disappear, so that if the value of x in the polynomial here is a, then we are able to get the remainder. Now if the value of x, if we put the value of a here and we calculate and we get our value of r as 0, then it means that this divisor is a factor of that polynomial. So this is what constitutes the factor theorem. Like in our write up here, it is saying that if x minus a, which is the divisor here, is a factor, then r is equal to 0. This will be equal to 0 if this is a factor. If this is not a factor, then we will get a certain remainder. It could be 2, 3, or whatever number. So if r is equal to r, it will be equal to 0 if p, when we have put a in that, when we substitute a in the polynomial and we get the answer as 0. Therefore, if p of a is equal to 0, then x minus a is a factor, and that is what is constituting the factor theorem. So let's do an example. Looking at that example, they're telling us that show that this polynomial is divisible by x minus 2. Hence, find the other factors of the polynomial. So now, if this factor is divisible by this polynomial, if this polynomial is divisible by x minus 2, then it means this should be equal to 0. X minus 2 should be equal to 0. Therefore, if we are to show that this factor can divide this completely, it means that our value of x should be equal to 2. If we put this value of x, which is 2, we put it in this polynomial and our answer is equal to 0, then it means that there is no remainder, and it means that this x minus 2 is a factor of that. So we begin. So it means that 2x cubed plus x squared minus 13x plus 6 is equal to 0. So we substitute. So it becomes 2 into 2 cubed So when we substitute for the value of 2 in this polynomial, we are going to end up with 0. So that means that indeed, therefore, x minus 2 is a factor. Now, if x minus 2, we've proven that it's a factor. Hence, find the other factors of the polynomial. So we need to find the other factors of this polynomial. So we use long division to find the other factors of the polynomial, like this. 2x cubed, divide that by x, you will get 2x squared. So 2x squared multiplied by x is going to end up with 2x cubed. Then 2x squared times negative 2 will end up with negative 4x squared. When we subtract these two, this minus that will remain with nothing, 0. The x squared minus negative 4x, this will become a positive. So this plus that is going to give us 5x squared. Then we pull these other terms down. Here we have minus 13x plus 6. We continue. 5x squared, divide that by 5, you'll end up with, this is positive 5x squared, divide that by 5, divide that by x, you'll end up with 5x. So it becomes plus 5x. 5x times x will give us 5x squared. Then 5x times negative 2 will give us negative 10x. So this minus that will give us nothing, 0. Negative 13x minus negative 10x. Of course, this minus and that minus will become positive. When it becomes positive, it is 13x. Negative 13x plus 10 will give us negative 3x. So it's negative 3x, then plus 6. This one comes down, plus 6. So we continue. Negative 3x, divide that by x, you will remain with negative 3. So negative 3 times x will remain with negative 3x. Then negative 3 times negative 2, you will remain with positive 6. And when we subtract this minus that will remain with nothing. 6 minus 6 remain with 0. So you will find that when you get this polynomial, you divide it by that divisor, you will get this quotient and no remainder. So it means our general term, which is our polynomial, which is p of x, is supposed to be equal to the divisor, which is x minus a, times our quotient q of x plus our remainder. But now here we are tasked to find more factors of this polynomial. One of the factors we have found is that one. The other factors that we need to find we're supposed to simply prime factorize this, because this becomes p of x is going to be equal to x minus a. We have x minus 2. Multiply that by the quotient, which is 2x squared plus 5x minus 3. Now the remainder is 0 plus r. Our r is 0 because these are factors, so even if we don't include it. So to get other factors, we simply need to factorize this quadratic equation. So factorizing that quadratic equation, it means that we're supposed to get two numbers. One of those numbers giving us a sum of positive 5, and the other number is giving us a product of negative 3 times 2, which is going to give us negative 6. So if we land on 1 times 6, 1 times 6. 1 times 6 will give us 6, not negative 6. So if we made this a negative, 1 times negative 6 gives us negative 6. 1 plus negative 6 gives us negative 5. So let's make 1 negative. This is positive. So negative 1 times positive 6 gives us negative 6. Negative 1 plus positive 6 gives us positive 5. So the two numbers will be negative 1 and 6. So we'll use those two to replace this middle term in our prime factorization. So prime factorizing this is going to become, we'll continue with that later. This prime factorizing 2x squared plus 5x minus 3 is going to become 2x squared. Now this plus 5x is replaced by these two, so it's going to be minus x plus 6x. Then we come to this minus 3. So that is going to become, we pull out the common terms. The common factor here is x, so it becomes x into 2x minus 1. That is plus, what's the common factor here? 3. So it becomes 3 into 2x minus 1. And then our answer here will be, we have the common terms in the brackets being the same, so it becomes x plus 3 into 2x minus 1. So this, now we've prime factorized this quadratic equation. So these now come and replace this. It means that our original statement there is going to become p of x, which is our polynomial, is going to be equal to x minus 2. Multiply that by this, which has now become this, x plus 3 into 2x minus 1, like that. So now they're asking us, our question was requiring us to find the other factors in the of this polynomial. One of those factors was already given to us, it was x minus 2. So it means the other factors are x plus 3 and 2x minus 1, and that's the answer. In this example, we are required to show that this 2x minus 1 is divisible by this polynomial 12x cubed plus 16x squared minus 5x minus 3. And afterwards, you're supposed to factorize it and solve this expression. By solving this expression, it means they are asking us to find the values of x for this polynomial, which is to the order 3. So we start. So now for us to show that this 2x minus 1 is divisible by this polynomial, it means that this 2x minus 1 should be equal to 0. We equate it to 0 and we get the value of x by making this x the subject of the formula. After making the value of x the subject of the formula, we substitute it into this polynomial, and if when we substitute it in, our answer is such that it is 0, then it means that this is divisible by that polynomial, and so we will have shown that this polynomial is actually divisible by 2x minus 1. So we begin. So if this is to be divisible by that, then 2x minus 1 should be equal to 0. And when to get the value of x that we are supposed to substitute into this polynomial, it will mean that x is going to be equal to a half. So we substitute a half in that. Our p of x, our polynomial, is equal to 12x cubed plus 16x squared minus 5x minus 3. So that's going to be equal to 12, substituting a half here, cubed plus 16. Polynomial here, on substituting in for that value of x, we got 0. Then it means that this is equal to 0. So now the question is further asking us that, hence, factorize the expression and solve for this, for the value of x. So this is a polynomial with a degree to the power 3. So we go ahead and factorize it, but first we are going to do long division so that we dismantle it into a simpler way for us to be able to factorize it. So we shall first use long division to divide this by this factor, knowing that our remainder will be 0. So factorizing it, we divide 12x cubed plus 16x squared minus 5x minus 3, divide that by 2x minus 1. So 12x cubed divided by 2x, we shall get 6x squared. 6x times 2x is going to give us 12x cubed. Then 6x squared times negative 1 will get negative 6x squared. When we subtract these two, 12x minus 12x, this is 12x cubed. 12x cubed minus 12x cubed, we will get nothing, it's 0. 16x squared minus negative 6x squared, we'll be getting 22x squared. So we pull this down. So this here will remain with 5x minus 3. So we repeat the procedure. 22x squared, divide that by 2x, you're going to end up with 11x. So it is plus 11x. So 11x times 2x is going to give us 22x squared. And then 11x times negative 1, we shall get negative 11x. When you subtract this minus that, will remain with nothing. Then negative 5 minus negative 11x, we shall end up with positive 6x. So remain with 6x. Then this negative 3 simply comes and joins here, minus 3. It comes down. So 6x divided by 2x will end up with 3. So here we answer it's plus 3. Now 3 times 2x is going to give us 6x. Then also 3 times negative 1 is going to give us negative 3. When we subtract this minus that, we get nothing. Negative 3 minus negative 3, we get nothing. So we are having our polynomial 12x cubed plus 16x squared minus 5x minus 3. When we divide it by this linear function 2x minus 1, we shall end up with the quotient being 6x squared plus 11x plus 3. So it means, according to our general setup for the polynomial, when we divide, this is the value, our polynomial p of x, it's going to be equal to this times that, with no remainder. So our polynomial p of x is going to be equal to this 2x minus 1 times that, times 6x squared plus 11x plus 3. Of course, plus our remainder, but our remainder is equal to 0. So even if we ignore that. So since this, we factorize this further. So this is going to be 2x minus 1. We factorize this quadratic expression. Factorizing that quadratic expression, we're supposed to get two numbers, giving us, when we add them up, they're supposed to give us positive 11, and when we multiply them, they're supposed to give us 6 times 3, which is 18. So these two numbers, when we add, those numbers should give us a sum of positive 11 and a product of 6 times 3, which is 18, and a product of 18. And these two numbers are 9 and 2. 9 times 2 is 18. 9 plus 2 is 11. So these two numbers are the ones going to replace that middle bit. So it means that our calculation will continue by saying it is going to be 6x squared plus 9x plus 2x, 9x plus 2x plus 3. That's going to be it. So this will become 2x minus 1 into, now this is going to, we factorize out this and that. So the common factor here is 3x, so we pull 3x out of the brackets, it becomes 3x into 2x plus 3. That is plus, there is no common factor here, so it's plus 1 into 2x plus 3. So that's going to become 2x minus 1 into, what is inside the brackets is the same, so it's going to become 2x plus 3 into 3x plus 1. And our answer is going to become 2x minus 1 into 2x plus 3 into 3x plus 1. Now these times, these are factors of this polynomial p of x. So originally our polynomial p of x, which we are calling this, is equal to that. We have factorized it. For us to be able to get the value of x, it means that this should be equal to 0. So when p of x is equal to 0, our polynomial is equal to 0, then it means that this is also equal to 0. So if these three factors, when you multiply these factors, you're supposed to get 0, it means that either this one is 0, or that one is 0, or that one is 0. And it's from there that we are going to get our value of x. So our value of x is either half, or it's negative 3 over 2, or negative 1 over 3. And that is how we solve for that polynomial. Now the expression x squared plus bx plus c is divisible by x minus 1. So if it is divisible by x minus 1, it means that when we substitute for the value of x in this expression, we are supposed to get 0. Then it continues to say that it has a remainder 2 when it's divided by x plus 1. And it has a remainder 8 when it's divided by x minus 2. So we find the values of a, b, and c. Now a, b, and c, this is our polynomial, and our polynomial so happens to be a quadratic equation. So it means that our polynomial is ax squared plus bx plus c. That is our polynomial. Now if our polynomial here is divisible by x minus 1, then and there is no remainder, or when the remainder is 0, it means that for the polynomial, when the value of x is 1, is equal to 0. What do I mean? I mean that if x minus 1 gives you a remainder of 0, now it means that for the remainder to be 0, it means that x minus 1 should be equal to 0. So x should be 1. P of 1 should be equal to 0. Meaning that when our value of x is 1, so we put here 1, 1, it means that a plus b, b times 1 is b, plus c is equal to 0. That's our first equation. Then, in the second part of the question, they are telling us that it has a remainder 2 when divided by x plus 1. And so meaning that if we are to substitute our negative 1 into that expression ax squared plus bx plus c, then our second equation becomes a minus b plus c is going to give us 2. That's our second equation. Then in our third statement, they are telling us it gives us a remainder of 8 when so when we make x the subject of the formula here, it means that our value of x is going to be equal to 2. So it means that our polynomial, the value of our polynomial when x is 2 is equal to our remainder, which is 8. So it means that for a, if we are put the value of 2 into ax squared plus bx plus c, it becomes 4a plus 2b plus c is going to be equal to 8. That's our third equation. So now we have 3 equations here that we are supposed to solve simultaneously. These 3 equations are that we are supposed to solve simultaneously. So we are going to first pair equation 1 and equation 2. We get one equation. We pair equation 2 and equation 3. We get another equation. So those 2 new equations we will have gotten, we will solve those 2 again simultaneously and we get what we want. Now the strategy we shall approach here is that we shall seek to eliminate b in the first 2 instances. So let's first pair these 2 equations. We have a plus b plus c is equal to 0, and then we have this one, a minus b plus c is equal to 2. Now if we are to eliminate b in this equation, if we simply add these equations, this equation plus that equation, b plus b here, this will disappear. So it means that if we add those two equations, we shall end up with a plus a, that is going to be 2a, c plus c is plus 2c, is equal to 0 plus 2, which is going to be 2. I mean b plus b here, it is 0. So here we have our first equation. So now we pair equation 2 and equation 3 to get another equation, but with the intention of eliminating b. So when we pair those two, a minus b plus c is equal to 2. Then we have this one, 4a plus 2b plus c is equal to 8. Now for us to be able to eliminate b here, here the coefficient of b is 2, here the coefficient of b is negative 1. If the coefficient of b here was 2, negative 2, it would simply be negative 2b plus 2b. Negative 2b plus 2b would make this 0. The value of b will disappear. So what do? We make sure that we multiply the equation above by 2. So we multiply this equation times 2. So it means that our first equation, the equation will now become 2a, 2 times a is 2a, 2 times b is minus 2b, 2 times c is plus 2c is equal to 2 times 2, which is 4. Then this one remains the way it is. 4a plus 2b plus c is going to give us 8. So now we can just add this equation and that equation, because when we add 2b plus 2b, negative 2b plus 2b will be 0. So 2a plus 4a is going to be 6a plus 0. 2c plus c is 3c. So it's plus 3c is going to give us 8 plus 4, 12. So that's our other equation. Let's call this was equation 1, 2. Let's call this equation 4. We call this equation 5. These are our two found equations. So now we have two new equations. We have this equation with a and c. We have this equation with a and c. We have eliminated b. So we have two new equations, so we solve them simultaneously to get the values of a and c respectively. So we can still continue that looking at these equations. We can simplify this equation further, by the way. 6a plus 3c is equal to 12. If we divide through by 3, simplifying it further, this would turn out to be, if we divide here by 3, by 3, by 3, this becomes 2a plus c is equal to 4. That will still be our equation 5. So now we solve these two simultaneously. When we solve the two equations we are solving simultaneously are 2a plus 2c is equal to 2. Then we have 2a plus c is equal to 4. 2a plus 2c is equal to 2 is our fourth equation, and this is our fifth equation. So we solve those two simultaneously. Still by elimination method, we are having 2a, 2a, so it's easy to eliminate a. If we subtract this equation minus that equation, we get here 0. So eliminate a and get c. So 2a minus 2a is 0. 2c minus c will give us c. That's going to give us 2 minus 4. 2 minus 4 is going to give us negative 2. So it means that our value of c is negative 2. If our value of c is negative 2, then we can substitute in either this equation or that equation to get our value of a. So we start working backwards. Our value of c is that. Our value of a will be 2a plus c is going to give us 4 from that equation. So meaning value of c here will be 2a. C is negative 2, so we say minus 2 is giving us 4. 2a definitely is going to become 4 plus 2. So our value of a is going to become 3, and so we substitute that in our original equations. A plus b plus c is equal to 0 to get the value. A plus b plus c is equal to 0. Our value of a is 3 plus the b we are looking for plus our value of c, which is negative 2. And so that's the answer. We have our value of b as -1, a as 3, c as -2. Called the polynomial p of x is divided by x minus 2, the remainder is -2. And when it's divided by x minus 3, the remainder is 3. Find the remainder when it is divided by that. Okay, so we begin. When the polynomial is divided by, the polynomial first of all is p over x, p of x. Now when it's divided by x minus 2, it means that the value of x is going to be 2, because x minus 2 equal to 0. It means that making x the subject of the formula, the value of x will be 2. So it means that p, when the value of x is 2, is going to be equal to the remainder. What's the remainder? -2. And when it is divided by x minus 3, it means that p into this means when 3 comes to the other side of the equation, it becomes, when the value of x is 3, is going to be, the remainder is 3. So find the remainder. So they're asking us to find the remainder when it is divided by that. Now this, when we multiply this by that, you get a quadratic equation. Let's say let the remainder be ax plus b. Now from our previous videos we said that a polynomial p of x will be equal to the quotient q, the quotient plus the divisor, which is x minus a, plus the remainder. Now in this particular case, our polynomial p of x is going to be equal to the quotient times the divisor. In this case they're asking us find the remainder when the thing is divided by x minus 2 and this. So it means that for the divisor part, it's going to be x minus 2 and that is x minus 2 into x minus 3 plus our remainder. Let our remainder be ax plus b. So since they're asking us to find the remainder, so we are going to be tasked to look for the value of a and b. That's going to be plus ax plus b. As simple as that. So now, so when p is 2, we substitute for 2 here and formulate an equation. When p is 2, so for the value of the polynomial p to be 2, that's going to be equal to, when 2 is, we put 2 here, 2 minus 2 is going to be 0. So 0 times this whole thing, this whole term dies. So we remain with this. So it going to become 2a plus b. It's going to be 2a plus b. But we know that when for the polynomial where the value of x is 2, we get a remainder of -2. So it means that this is going to be, -2 is going to give us 2a plus b. That gives us our first equation. So now we do the same for when the value of x is 3. So for p into 3 is going to be equal to, when we feed in 3 here, 3 minus 3 is going to be 0, so this whole term will die and remain only with this. So it's going to be 3a plus b. 3a plus b. So remember, p of 3 is 3, so this is going to become 3. 3 is going to give us 3a plus b. That's our second equation. So we have two equations. All we have to do is simply solve them simultaneously. We have, what can we easily eliminate? We can easily eliminate b. So we simply subtract this equation from that equation to eliminate b. So -2 minus 3 is going to give us -5, is giving us 2a minus 3a, giving us minus a. So meaning that our value of a is going to be 5, and when you put 5 there, our 3 is giving us 3a plus b. 3 times 5 is 15. Our value of b will be -12. So to substitute all this in our ax plus b, it means the remainder is 5x minus 12, and that's the remainder. Let's carry out a similar example. A polynomial f of x gives a remainder 4 when it's divided by x plus 2, and a remainder 2 when it is divided by x minus 2. Find the remainder when the polynomial is divided by x squared minus 4. We'll do like we've done before. So if the remainder is, if the polynomial is f of x, and we know that f of x, when it is divided by, f of x is going to be equal to the quotient. The polynomial f of x is equal to the quotient times the divisor plus the remainder. So it means that here, when divided, so when it's divided by x plus 2, it means that x will be equal to negative 2. And when we put x into negative 2 into that polynomial, our remainder to be 4. And they're asking us, and the remainder 2 when divided by x minus 2. So when it's divided by x minus 2, it means our value of x is going to be 2. So when we put 2 in that place of x, it means that our remainder is supposed to be 2. So they're asking us to find the remainder when the polynomial is divided by x squared minus 4. So let our remainder be in terms of x plus b, then we find that. Let our remainder be equal to ax plus b. So we begin. When we divide this by, when we put our value of negative 2 there, that's going to give us the quotient times our times the divisor. Our divisor here, they are telling us that find the remainder when the polynomial is divided by x squared minus 4. It means that this is going to be our divisor. So it is multiply that by x squared minus 4 plus our remainder. And our remainder in this case is going to be ax plus b, what we are looking for. So we start substituting. When the function of x is negative 2, that's going to be, now here negative 2 squared is going to be 4. 4 minus 4 is going to be 0, so this whole term is going to die and remain with negative 2a plus b. And we know that this f of negative 2 is giving us 4. So it means that 4 is going to give us negative 2a plus b. That's our equation 1. So we go to the second case when our value of x is 2. When we put our value of x here, 2, f of 2 is going to be equal to, when we put our value of 2 here, 2 squared minus 4, this is going to be equal to 0. So it means this whole term is going to die. 0 times this is all 0. We remain here with 2a plus b. It's going to give us 2a plus b. That's it means that our function of 2 gives us 2, so it's 2 is going to give us 2a plus b. That's our equation 2. After getting our equation 2, so it means that for us to get the values of a and b, we solve these two equations simultaneously. So how do we solve these two? We simply eliminate b. It's easy to eliminate. Subtract this minus that. So 4 minus 2 is 2. It's going to give us negative 2 minus negative 2 is negative 4a. And then b minus b is 0. So we've eliminated b. So we divide both sides here by negative 4. By negative 4, this goes with that. Our value of a here is going to be negative a half. So our value of b will be, it will be, if we make b the subject of the formula in this equation, it's going to be 2 minus 2a. So our value of b is going to be 3, and our value of a is going to be negative a half. So from ax plus b, our factor is going to become, our value of a is negative a half, so it's negative a half x plus 3. And that is going to be the factor we've been looking for. If the expression ax to the power 4 plus bx to the power 3 minus x squared plus 2x plus 3 has a remainder 3x plus 5. When it is divided by that, find the values of a and b. This means this is our divisor, because they're telling when it is divided by that. This is our remainder, and this is our polynomial. Let's first state those categorically. Our polynomial is ax. Our remainder is that. And our divisor is that. They're asking us to find the values of a and b. In our polynomial, our divisor and our remainder look like that. Now, we all know that our polynomial is going to be equal to the product of the quotient times the divisor plus the remainder. And in this case, our polynomial is this is equal to our quotient times our divisor, which is going to be that, plus our remainder, which is going to be 3x plus 5. So our polynomial is saying that ax to the power 4 plus bx cubed minus x squared plus 2x plus 3 is... This is supposed to be our quotient times our divisor plus the remainder. They're asking us to find for the values of a and b in this polynomial. We all know that if p of x is equal to the remainder, if p of x is to be equal to the remainder, then it means that this whole term should be equal to 0 for that to be possible. For p of x to be equal to r, it means that this whole term must be equal to 0. So it means that in respect to that, if we're looking at this polynomial, it's going to be equal to this, the product of the quotient and the divisor, plus the remainder. It means that this whole term must be equal to 0. So now let's get the values of x for which this term is equal to 0. After getting the values of x for which this term is equal to 0, then we shall come back to this same expression, fill in those values of x so that we are able to get the values of a and b. So what we are going to do is this. We are going to look for the value of x here, for which this term is going to be equal to 0. It means we are going to prime factorize this expression and get our value of x, for which we'll make this whole term 0. After getting our value of x, then it means we are going to come and substitute it in this whole expression, so that we form simultaneous equations which we shall later solve so that we get our values of a and b. So we start working. So meaning for x, so we factorize that quadratic expression and we get our value of x. So this is going to become x squared. We get two numbers when we are prime factorizing two numbers. Two numbers should give us a sum of negative 1, and when we multiply them, they should give us a product of negative 2. And these two numbers are going to be, it's going to be negative 2 and 1 and positive 1. It's going to be negative 2 and positive 1, because positive 1 plus negative 2 is going to give us negative 1. Then positive 1 times negative 2 is going to give us negative 2. So these two numbers are going to replace that middle term. So it means it's going to be x squared plus 1x. So it's supposed to be plus 1 minus 2x minus 2 is going to be equal to 0. So this becomes like that. So we have gotten our values of x for which this expression is equal to 0. When we substitute for 2 or negative 1 in this expression, we shall get 0. So now we substitute for these values of x in this expression. We know that when we substitute for the values of x in this expression, this whole term will be equal to 0, and so we shall be remaining with this expression is going to be equal to 0 plus that expression. So we shall substitute here for the value of x when it is for the two values of x we have gotten. Then we are going to form two simultaneous equations that are going to help us to get the values of a and b. We proceed. That's our first equation. Then in second equation, still we are going to substitute in that same expression for values of x, which is going to be -1. So we shall end up with our value of our expression here as a minus b is equal to 2. So our first equation is a minus b is equal to 2. Our second expression is 16a plus 8b is equal to 8. So we shall solve those two equations simultaneously, most easily by substitution. So we shall substitute the value of a here. If we make a the subject of the formula here, it's going to be a will be equal to 2 plus b. So we substitute for the value of a in this expression and we get our value of our values, our answer. So it's going to mean 16 into a, which is 2 plus b, plus 8b is equal to 8. So we calculate and get our value of b. So here we shall end up with our value of b as -1. When we substitute our value of b in this expression, we shall get our value of a as 2 plus b, which is -1, which is going to be 1. So our value of a is 1, our value of b is -1. Today we get to look at synthetic division. Synthetic division is simply a method that we can use to find the quotient and the remainder of a polynomial. But with this kind of method, we are simply going to detach coefficients from the polynomial and we work with coefficients. Use this example. Find the quotient and the remainder when 3x cubed minus 5x plus 10 is divided by that factor using synthetic division. So the polynomial in question is this. It is 3x cubed. So if you look at that coefficient, we are having x to the power 3. We have coefficients 3, -5, and 10. So now we are going to group this in this way. We shall put here the coefficients of x. Our highest power is 3. So we put here the coefficients of x to the power 3, x to the power 2, x to the power 1, x to the power 0. So it means that our coefficient of x to the power 3 is 3. So we put here the 3. The x to the power 2, we do not have any term that is x to the power 2, so that is 0. Our coefficients of x to the power 1 is -5. Our coefficient of x to the power 0, any number to the power 0 is 1, so the number here is 10. Like that. And now, so after stating those coefficients, they are telling us that this polynomial is divided by x minus 2. So if it is divided by x minus 2, meaning that if we say x minus 2 is equal to 0, it means the value of x is going to be +2. So we put the +2 here. We put a 0 at the first step here. So now we start working. So for us to get these remaining gaps, it's going to be this number times that number plus this number times that number to give us that. 2 times 0 is 0 plus 2 times 3 is 6. So it means our answer here is 6. 2 times 6 is 12 plus 2 times 0 is 0. So 0 plus 12, we get 12. So we put the 12 here. We do the same. 2 times 12 is 24. Then 24 plus 2 times 5. 2 times 5 is negative 10. So negative 10 plus 24, we shall get 14. Put the 14 there. So after filling in all these, then we simply add them to get new terms here. So when we add 3 plus 0, we get 3. 0 plus 6 is 6. Negative 5 plus 12, we get 7. And then 10 plus 14, we get 24. So now, after getting our figures like that, now this last number here is what is going to give us the remainder of the number. This is the remainder, and then this gives us the quotient. And the quotient we get here, the value of x will start counting from this. We're going that way. The value of x here will be 0, 1, 2. The power to x is 0 here, the power to x is 1, the power to x is 2. So it means that our answer here, because they're asking us that, find the quotient and the remainder when that is divided by that. So it means here our answer is going to be, our quotient will be 3x squared plus 6x to the power 1, because it's to the power 1, plus 7x to the power 0 is 1, so it's plus 7. That will be our quotient, and our remainder is 24. That is the answer. So now let's do one more example. X to the power 5 plus 1 by x plus 1 using synthetic division. We are going to do the same. Our highest power is 5. So if our highest power is 5, it means that we are going to name from x to the power 5. X to the power 5 will be there, x to the power 4, from x to the power 5, 4, 3, 2, 1, 0. So right here we are going to put the coefficients of these terms. Coefficient of x to the power 5 is 1. So we'll put there 1. X to the power 4, we do not have x to the power 4 in this, so it is 0. X to the power 3, we do not have x to the power 3 here. X to the power 2, we have nothing like x to the power 2. X to the power 1, we have nothing like x to the power 1. Then x to the power 0, any number to the power 0 is 1. So that is like the whole number, that is going to be 1. And now, this is divided by x plus 1. So it means that we are going to, when x plus 1, if x plus 1 is equal to 0, making x the subject of the formula means that our value of x is supposed to be negative 1. So we put a negative 1 there. When we put our negative 1 there, the first place here we put is 0. So now we get these remaining figures. This times that plus this times that gives us that next figure. This times that next figure plus this times that gives us this. This times that plus this times that gives us that. And so on and so on. So we start. Negative 1 times 0 plus negative 1 times 1 is going to give us negative 1. Negative 1 times negative 1 plus negative 1 times 0 is giving us 1. Negative 1 times 1 plus negative 1 times 0 is going to give us negative 1. Negative 1 times negative 1 plus negative 1 times 0 is going to give us positive 1. Negative 1 times 1 plus negative 1 times 0 is going to give us negative 1. Then you go on and add this, that up to the end. So 1 plus 0 here is 1. 0 minus 1 here is negative 1. 0 plus 1 is 1. 0 minus 1 is negative 1. 0 plus 1 is 1. And 1 minus 1 is 0. So from that we get our last term here, just like in our previous number, is supposed to give us the remainder. So it means here our remainder is going to be 0. So that is our remainder. And then our quotient is that. Now for our quotient, the powers of x are labeled counting from here 0 going that way. So the value of x for this is going to be from 0, 1, power 2, power 3, power 4. So it means that our remainder is 0 and our quotient is going to be equal to x to the power 4, because it's 1x to the power 4, minus 1x to the power 3. So that is minus x to the power 3. Then that's going to be plus, because it's positive 1, plus 1 to the power 2, plus x to the power 2, minus x to the power 1, minus x to the power 1, then plus 1. So that will be our quotient, and that is going to be our remainder. Today we get to look at equations with symmetrical coefficients. Solve that equation. Let's solve this equation. The first step with this, we divide this equation through by x squared. When we divide through by x squared, the equation will become so we collect like terms. 5x plus 5 over x squared we equate this to 0, so this is also equal to 0. So after collecting like terms, we factorize out the common term here. The common term here is going to be 5. The common term here is 16. Minus 42, that's going to give us 0. Since we have put this in the brackets, let's say, let m, let's call this a letter, let m so if m is equal to x plus 1 over x, so it means that this can be the value of m. Now what about this? Let's try and square m. M squared will be equal to so meaning that our m squared is going to become x squared plus 2 plus 1 over x. So if we make it look like this, like this, m is equal to x plus 1. So if we make it look like that, this expression, it means we are supposed to remove these 2 from here. So it means m squared minus 2 is going to become x plus 1 over x. So after getting our values of m, here we got m squared is supposed to be equal to x plus 1 over x. So we substitute for this, we put m squared in this expression. Then in this expression, x squared plus 1 over x squared, we are going to put this expression there. And then our equation is going to become like this. Our equation was originally, it was 5 into our value of m is x plus 1 over 2, so this is going to become m. And m squared minus 2 is equal to x squared plus 1 over x. So this term we are going to substitute for, and we simplify the equation. Now we have simplified our expression. It has become a quadratic equation. So now all we have to do is find the value of m. After finding the value of m, we come substitute it here and we get the respective values of x. And that is how we will have solved this equation with symmetrical coefficients. So after getting our values of m, remember that at first m is equal to x plus 1 over x. So now we begin. When m is negative 2, what is x? Our value of x there is going to be negative 1, and that is one of the factors of that polynomial, and so this is going to be a repeated factor. It is a repeated factor because it's both positive and negative 1. So our first value of m was negative 2, and when our value of m is negative 2, we put m here, our value of x we get is negative 1. So when m is negative 26 over 5, let's get the value of x that is corresponding. So when the value of m is 26 over 5, we get our value of x as either 5 or a fifth. So it means for us, the final answers, the factors of this polynomial are going to be 5, a fifth, and this negative 1, which is a repeated factor. So those are the roots of the polynomial. We have here yet another equation that has got symmetrical coefficients. Just like though we did in our previous video, we are going to divide through by x squared. We divide through by x squared and we get a new expression. When you divide through by x squared, it's going to become 3x to the power of 4 divided by x squared is going to give us 3x squared minus 4x cubed divided by x squared is going to give us 4x minus 14 minus 4 over x plus 3 over x squared is equal to 0. So now from this we collect like terms. We put those that are squared together. 3x squared plus 3 over x squared minus those terms that have only x, minus 4x minus 4 over x, then the whole numbers alone, minus 14, is giving us 0. So we factorize this out here. 3 is the common term. 3 into x squared plus 1 over x squared minus 4 is the common term here into x plus 1 over x is equal to minus, that is minus 14, is giving us 0. So let us make this n, let n be equal to x plus 1 over x. So the value, we've called this n. So now let's also make this become n as well. So we square both sides for this. If I skip this, so squaring here both sides becomes n squared is going to be equal to x plus 1 over x squared. So when we square both sides here, this expanding this is going to become x squared plus 2ab plus b squared 1 over x squared. So it will end up, we shall end up with our n squared will be x squared plus 2 plus 1 over x squared. For us to put this only on this side, we leave x squared plus 1 over x plus 1 over x, so this 2 comes that side. So it becomes n squared minus 2 is giving us x squared plus 1 over x squared. X squared plus 1 over x. So meaning that we have that expression as well. So what we do here is that we are going to substitute, this is x plus 1 over x, we substitute this value of n in that expression there. Then here we substitute this value of n x squared plus 1 over x, we put there n squared minus 2 here. So that our equation becomes more simpler and we find for the value of n. So we go ahead, so this is going to become 3 into n squared minus 2, which is substituting for that, minus 4 into this, which is n, that is minus 14, is going to give us 0. So now we concentrate on getting the value of n. We open brackets, formulate a quadratic equation, and solve. Concentrate on getting the value of n. So after getting our values of n, we shall substitute our value of n, we put our value of n here, n is equal to x plus 1 over x. So we substitute for the value of n we've got so that we get the corresponding values of x, which are coincidentally going to be the roots of the polynomial we are trying to solve for. From our previous workings, we know that n is going to be equal to x plus 1 over x. N is 10 over 3, so 10 over 3 is going to be equal to x plus 1 over x. So we solve for the value of x. We multiply 3 throughout and we make it a flat equation and reorganize it and get that. We end up with a quadratic equation here. Solving this quadratic equation is going to give us x. X will either be a third or x is going to give us 3. That is when the value of n is 10 over 3. What about when the value of n is 2? So when the value of n is negative 2, so from this quadratic equation we find that x plus 1 is equal to 0. So x is going to give us negative 1, and this is a repeated. That's a repeated factor. So for our polynomial in the question, the values of x are going to become roots. Now, when we are having equations that are involving square roots, we are supposed to square both sides of the equation so that we eliminate that square root sign. Equations of this type, like the we are seeing, are solved by eliminating squares. And if you are to eliminate these square root signs, it means you're supposed to square on both sides. Now, wherever both sides of an equation are squared, it means that we are creating an extra solution. For example, if we are having x squared is equal to 4, it means that the value of x here is going to be, if we find the square root of 4 and the square root of x squared on both sides, the value of 4 is going to become either positive or negative 2. So, if the value of 4 is positive or negative 2, the value of x, then it means that the extra solution here is the negative 2. That's the extra solution I'm talking about. So it means, since on squaring both these sides, we are going to be creating an extra solution for the value of x, then for all equations involving squaring on both sides, all roots that we get at the end of calculus, all the roots we get must be checked in the original equation. Because since we have created some extra solutions, it means that some of those solutions will not be consistent with this. So we are going to solve for the value of x. After getting the value of x, we are supposed to come back and fill them in here. If it is consistent that when we fill it here it satisfies this equation, then it means that value of x is correct. If it does not, then it is not. So we start. This plus that is equal to that. So we square both sides to get what we want. So it means that we are going to square this side and also square that side. So when we square both sides of the equation, we shall get this squared plus 2 times this times that, plus this squared. And that is going to be equal to that squared. So when that is squared, this square root sign, this is going to become like that. So we go to our next step. So it means that this square root sign dies with that. So this, we are going to remain with 3x plus 1 plus 2 into that is plus that is going to give us this squared. This square root sign goes with that, it remains like that. Now here we square both sides so that again we eliminate that square root sign. And so squaring both sides of this equation is going to make this become, meaning this is squared and that is also squared. This is going to become we are multiplying this by that to get that. So from here, from our answers here, either x is going to be equal to negative a third and or x is going to be equal to 5. X is one of those. So we have gotten two values of x for that polynomial. But remember, for this expression in our question. We've got two values of x for the expression in our question. But since we squared both sides, it means that we created an extra solution. And we said that for all equations involving squaring on both sides, all roots must be checked from the original equation. So when we put this value of x in our original equation, it is consistent. When we put this value of x in our original equation, it's still going to be consistent. So it means that both are correct. So this is a correct root and that is also a correct root. And that is our answer. So we are going to solve this equation. It is an equation that is involving square roots. In our previous video, we said that equations of this type are solved by squaring both sides. And when we square both sides, it means that we are going to create an extra solution. Solving this, it means that we are going to square both sides. It means we are going to square here, and we square this as well. Squaring both sides, this is like a minus b squared. So it means that is going to give us that squared. This squared is going to give us x plus 2 minus 2ab, so minus 2 times x plus 2 into 2x minus 3 plus this squared, which is 2x minus 3, that is going to be equal to this squared, and that is going to give us 9 into x minus 5. So we collect like terms. We add this to that term, and adding this to that term is going to become 3x minus 1, then minus this, minus 2 under the square root of x plus 2 into 2x plus 3 should be giving us, now this is going to become 9 times 3 is 27x, then 9 times negative 5 will give us minus 45. It moves to that side of the equation so that we remain with only the square root term this way. So this way it remains as negative 2 into x plus 2 into 2x plus 3 is going to give us, now 27 minus 3x is going to give us 24x. Then negative 5 plus 1 is going to give us minus 44. Now, again, to eliminate this square root sign, we square both sides. When we square both sides, it means this is squared and that is also squared. When you square both sides, we are going to end up with 4 into x plus 2 into 2x minus 3 is going to give us, squaring both that side is going to give us 576 x squared minus 2112x plus 1936. So this becomes, when we expand that 4 into this times that is 2x squared plus this times that plus this times that is going to give us plus x. Then 2 times negative 3 is going to give us negative 6. Is supposed to be equal to 576 x squared minus 2112x plus 1936. So when we open brackets, 4 times 2 is going to give us 8x squared plus 4 times x, that is going to give us 4x. 4 times negative 6 is going to give us minus 24. Should be equal to 576 x squared minus 2112x plus 936. So we formulate one quadratic equation from all this. So we merge this 576 and that 8x squared minus 576x squared is going to give us minus 568x squared. Then 4x plus 2112x is going to give us plus 2116x. Then negative 24 minus 1936, because this we are putting it this side, is going to give us minus 1960, and that is going to be equal to 0. So this is a quadratic equation that we have formulated. So we solve for that quadratic equation, we get the values of x. So if we are to use what we call the bulldozer method, the values of x is going to be minus 2116 plus or minus 2116 squared minus 4ab, 4 times our value of a, which is minus 568, 1960, divide all that by 2, multiply that by negative 568. So in there, our value of x with either going to be 245 over 142, or it's going to be 2. So now here, after getting our values of x, it's either this or that. So we test for our values of x. When we put this figure in, our values of x, when we put 2 in our expression to see whether it is correct, we find that on the left hand side it's going to give us 1, on the right hand side it's going to give us 3. So this is not a solution. But when we test by putting in this figure 245 over 142, then it means this value of x is going to be consistent with our equation. So this is correct. So it means that our value of x there is 245 over 142. So solving equations by reduction to quadratics and other simpler forms. For example, let's solve this equation. X squared plus 2x is equal to this. Find the value of x. So our first step here is that we are going to identify where the quadratic equation is. We are having a quadratic expression there, x squared plus 2x. We are having a quadratic x squared plus 2x. So if we formulate this into one letter, then this will become very simple to handle. So let's call it m. Let m be equal to x squared plus 2x. When we make mx be equal to x squared plus 2x, it means that this whole expression now becomes m is going to be equal to 34 plus 25 over m. So we multiply through by m to make this a flat equation, and then we work towards solving for the value of m. So when we multiply with m by m throughout, it becomes m squared is going to be giving us 34m plus 25. So it becomes m squared. This comes that way and that comes that way. It becomes minus 34m minus 25 should be equal to 0. So when all that is equal to 0, then solving for the value of m, so m is going to be equal to 34 plus or minus 34 squared minus 4ab. This is a is 1 and b is negative 25. All that, divide that by 2. So from here, our value of m is either going to be 34.7 or our value of m is going to be negative 0.72. But now remember, our m is going to be x squared plus 2x. So from m is equal to x squared plus 2x. Now what happens when m is 34.7? What are we going to get? So when m is 34.7, it means that 34.7 is going to be equal to x squared plus 2x. So we are going to end up here with a quadratic expression which is going to be x squared plus 2x minus 34.7. That is, if we rearrange it, is going to be equal to 0. So meaning from this quadratic equation, our value of x is going to be minus 2 plus or minus b squared, our value of b squared minus 4ac, because here the term is b squared minus 4ac. B squared is going to be, that is b is 2, so it is 2 squared minus 4 times a is 1 times c is negative 34.7. So our answer here, we shall get 4 plus 138.8 over 2. So our value of x here, x is either going to be 4.97, or it's going to be negative 6.97. So those are the values of x for when m is 34.7. Now what if m is negative 0.72? What are our values of x? So now when m is that, it means that our value of m will be equal to x squared plus 2x. So it's going to be negative 0.72. It's going to give us x squared plus 2x. So we formulate a quadratic equation which is going to be x squared plus 2x plus 0.72 is going to give us 0. So when you solve for that quadratic equation, this form, we will get our value of x being either negative 0.471 or our value of x is going to be equal to negative 1.53. It's either this or that. So meaning that for this expression, for our question, for solving for the value of x, it means, so to answer this question, the values of x that are satisfying this equation are the ones that we've gotten down here, are 4.97, negative 6.97, negative 1.53, and negative 0.471. Now in nonlinear simultaneous equations, here we deal with pairs of simultaneous equations with at least one being nonlinear. If you look at this pair, we are having, this is a linear equation, this is a nonlinear equation. So this is what we mean by nonlinear simultaneous equations. So how do we solve for that? So now, looking at equation 1, So for equation 1, we will call this our equation 1, and we will call that our second equation. So for my first equation, we will see that 4x squared minus 9y squared is going to be equal to 36. So this is the same as 2x squared minus, put all that in brackets, square root of 9 is 3, 3y squared is supposed to be equal to 36. If you look at this, this is a difference of two squares. This is like a squared minus b squared. So with difference of two squares, it's going to be 2x minus 3y is the same as 2x plus 3y is equal to 36. So now it means that our equation, this equation 1, has now become this. 2x minus 3y, 2x plus 3y is equal to 36. But if you look at our equation 2, our second equation, if we are to collect like terms, we put the whole numbers on the other side, on one side. This second equation of ours, from this second equation, we get that 2x plus 3y is going to be equal to negative 2. If we are to push this to this side. So from our second equation, we are seeing that 2x plus 3y is equal to negative 2. And in our first equation, we have simplified it into this. So since 2x plus 3y is equal to negative 2, and yet in this equation we're having 2x plus 3y, so it means that this is equal to 2. So it means that we are substituting this equation, we're substituting it into that. So from this equation, we shall continue here and say that 2x minus 3y multiply that by 2x plus 3y, which 2x plus 3y is equal to negative 2, is going to give us 36. So when it gives us 36, we simplify this. Now we've made this become linear. So we simplify it and it becomes negative 2 times negative 2 is going to give us minus 4x. Negative 2 times negative 3 is going to be positive 6y. Is going to give us 36. So now we have a linear equation. So now that we have gotten a linear equation, which is negative 4x plus 6y is going to be 36. So it means that we can now solve this linear equation with this linear equation simultaneously. And when you solve those two simultaneously, we will be able to get the value of x and y. So this equation is the same. If you divide through here by 2, it's the same as saying negative 2x plus 3y is giving us 18. Our first linear equation is that one we've gotten, which is 2x plus 3y is going to give us negative 2. The second linear equation is that one, which you are going to call negative 2x plus 3y is going to give us 18. Solving for those two equations simultaneously, we get our value of x. When we by elimination method, it means we eliminate the value of x. When we add 2x plus this, 2x plus minus 2x is going to give us 0. So 3 plus 3 is going to give us 6y. So we have here 6y is going to be equal to negative 2 plus 18, that is 16. So we divide both sides by 6. When we get a value of y as y is equal to 8 over 3, when we substitute for the value of y in one of those expressions, we'll get our value of x. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.